Hi everyone, welcome back to another video. In this video we are solving some applications of rational equations. So let's just jump into an example. Courtney walks 1 mile per hour slower than Brandy. In the time that it takes Brandy to walk 6.5 miles, Courtney walks 5 miles. Find the speed of each person. Okay, so the way that we want to set this up is we want to have the equation, the formula d is equal to rt, distance is equal to the rate times the time, or in other words, the distance is like the speed times the amount of time that you're going that speed. For example, if I'm traveling 60 miles per hour and 2 hours have gone by, then I will have traveled 60 times 2 miles. I will have traveled 120 miles. So that's just an example. But let's jump into the example that we've constructed so far. So what we've got is we've got to use the formula I just said. So let's think. Courtney walks 1 mile per hour slower than Brandy. In the time that it takes Brandy to walk 6.5 miles, Courtney walks 5 miles. So notice that they're saying that the times are the same, because they're saying in the time that it takes Brandy to walk 6.5 miles, Courtney walks 5 miles. So the times are equal. So what we might want to do is take what we've got above and just rewrite this formula a little bit using some algebra. So we already know how to solve for variables in equations like this, so we could just solve for t by dividing both sides by r. If we do that, we end up getting d over r equals t. So that's kind of the first step, is to rearrange the given equation for the information that would be helpful. So here we want to know what the time is, because the times are the same. We also just want to make sure that we've got every piece of information from the problem. We see that Courtney walks 1 mile per hour slower than Brandy. So that really, what that means is that if we call r the speed of, so we'll say call r the, I should speak a little more grammatically correct. Call r the speed of, let's just say, Courtney. Just choose either one, it doesn't matter. So I call r the speed of Courtney. Now Courtney walks 1 mile per hour slower than Brandy. So if Courtney's speed is r, then Brandy's speed, actually, you know what? I'm going to go back on what I just said. I think it's more simple to do it this way. You can do it either way, but I'm going to call r the speed of Brandy. Now, Courtney walks 1 mile per hour slower than Brandy, so Courtney's speed, Courtney would be, her speed would be r minus 1, because it's 1 mile per hour slower than Brandy. Slower, so we have subtraction here. Okay, so r is the speed of Brandy, r minus 1 is the speed of Courtney. Now, we know the times are equal. So if we take distance over the speed for both Brandy and Courtney, we can equate them and then solve for what we need. So let me be a little bit more specific with what I mean. We know that d over r is t. So with Courtney, we can say, since Courtney walks 5 miles, in that time, we can say 5 over Courtney's speed, which is r minus 1, is equal to the distance that Brandy traveled, 6.5 miles. So again, it's that d over r formula, over what's the speed of Brandy? Brandy's speed is r. So now we just need to solve this equation. You can do cross multiplication if you'd like. That's the route we'll take. we can write 5r is equal to 6.5 times r minus 1. And then we can distribute and solve for r. So we get 5r is 6.5r minus 6.5. We can subtract 6.5r, giving us minus 1.5r is minus 6.5. And then after dividing both sides by minus 1.5, we end up getting ourselves, I'm not sure, let's see, minus 6.5 divided by minus 1.5. What is that? I'm going to pull out a calculator because I'm actually not sure what that is off the top of my head. It is 6.5 divided by 1.5. It's 4 1/3. So you could have done that by hand, but save a little bit of time. 4 1/3 miles per hour. So r is 4 1/3 miles per hour. That's the speed of Brandy, right? So r is 4 1/3. That's the speed of Brandy. So the speed of Courtney. So this is Brandy. Just to reiterate. And then Courtney would be Courtney's speed. Courtney's speed would be r minus 1, so 4 1/3 minus 1, which is just 3 1/3 miles per hour. So we've just found the speed of each person. The speed of Courtney is 3 1/3. The speed of Brandy is 4 1/3 miles per hour. So that's one problem solved. The crucial part of solving that problem was noticing that the times were the same for each person. So we can solve for time in our formula, compute d over r for each person as we did here. This was d over r for Courtney. This was d over r for Brandy. And I suppose it's d over r minus 1 in this case because of what we know about the rate. But anyway, let's move on to the next problem. The next problem says that Fiona's Boston whaler cruised 45 miles upstream and 45 miles back downstream in a total of 8 hours. The speed of the river is 3 miles per hour. Find the speed of the boat in still water. So basically we've got this problem where you could be going upstream and then there's kind of a force against you, right? Whenever you're going upstream, you go a little bit slower. And then when you're going downstream, you have a force going with you, so you go a little bit faster. So we have to capture this. Maybe what I'll do is I'll set up a table. I could have done this in the last example. Feel free to rethink about how you could use a table in the last problem. So distance, rate, and then time. Remember that distance is rate times time, so maybe I'll write it like this. So when we're going, we'll have to think about this in two cases, right? When we're going upstream and when we're going downstream. So let's just do upstream first. And the rate you could think about as the speed again. Not all rates are speeds, but anyway, rate's a little bit more general. But anyway, we write all this out. We have our upstream distance of 45 miles. Our speed we don't know. We know the speed of the river. We know the speed of the current of that river that's either going against us while we're going upstream or going with us going downstream. So we can write the rate upstream. Here's how we'll write it. We'll let, I'll use a little, just to be a little bit more formal, let R be the speed of the boat in still water. So water that's not moving. Okay, so if R is the speed of the boat in still water, then if we're going upstream, remember, our speed will be a little bit slower. So we'll have r minus whatever that speed of that current is that's against us. So we'll just say it's r minus 3. Now, let's do the same thing. Notice I left off time, and I'll explain, or you'll see why in a moment, why I've done that. But now working downstream, we still are traveling 45 miles. They stated that right here in the problem. And then the speed, or the rate, is now going to be, you can probably guess it, it's r plus 3. Because now we've got that speed of the river going in the same direction as us. That current is in the same direction as us, so it's plus this time. Okay, now we want the speed of the boat in still water, and we know that the total time is 8 hours. So we don't know the individual times, but we do know the total time. We do know the total distance. It doesn't really make sense to add up the total rates, but we know the total distance is 90 miles. I don't think we'll use this in our problem, but anyway. And we know the total time is 8 hours. Now let's just pan down a little bit here. Okay. Okay, we've got the distance, we've got the rate, and we've got the total time. And that's ultimately, we got those for each, well, going upstream and downstream. So ultimately that, along with the total time of 8 hours, is all we need to do to solve for r. It's all we need to solve for r. So let's think of what we need to do. Remember, distance is rate times time. And we saw in the last problem that if we rearrange this, we get d over r is equal to time. Well, here we've got the total time is 8 hours. So what we'd like to have is basically two fractions that we're adding together. One for when we're going upstream, and one for when we're moving downstream. And we know the total time. So this is going to be some d over r, this is going to be some d over r, and we know that total time is 8 hours. So this is the time that it takes going upstream, say, and then this is the time it takes going downstream. So we know that the time for going upstream is going to be a little bit higher, but without really thinking about that, let's just plug in our stuff from our formula. Remember that we've got 45 on the top of both of these because it's the same distance either way, whether you're going upstream or downstream. They've stated that here, 45 miles upstream, 45 miles back downstream. You start where you end where you began. So anyway, let's divide now. Let's take 45, our distance, and divide by the rate. When you're going upstream, the rate is r minus 3. When you're going downstream, the rate is r plus 3. Okay, now ultimately we just need to solve this equation, and we've seen how to do that, but I will still go through it. Let's take both sides of this equation and multiply it by the LCM. The LCM is r minus 3 times r plus 3, so we'll do that. Kind of squeeze it in here. Maybe I'll do a different color too. Just to multiply by r minus 3 times r plus 3. Okay, so we have to do that to both sides of the equation. All right, so in doing that and carrying out this distribution, we end up getting, notice the r minus 3's are going to cancel, and we have 45 times r plus 3 plus 45, and then here the r plus 3's will cancel, so we got 45 times r minus 3. And then that's equal to 8 times r minus 3 times r plus 3. So that's 8 times, let's FOIL this out, but we know that we've got a difference of squares here, so this just becomes r squared minus 9. You can check for yourself that the middle multiplications would cancel out. And then we can distribute this, distribute all this stuff. Let's do all that pretty quick here. We're going to get 45r here, we're going to get 45r here. Those are going to combine to make 90r. Plus, and we've got 45 times positive 3, and then we got 45 times negative 3. So without even really thinking about it, I can just know those are going to cancel out. So maybe instead of a plus sign, I'm just going to put an equal sign. So this multiplication and this multiplication would cancel out in the end, so we can kind of set that aside. And then that would be equal to 8r squared, distributing, minus 72. Okay. So now we just need to solve this quadratic equation. We're going to get two answers, but only one answer will make sense. Let's pan this down. Let's solve this. Let's get it equal to 0, so we can subtract 90r from both sides, say. That would get it equal to 0 on the left, which is what would be nice. So we have 0. Excuse me, we get 0 is 8r squared minus 90r minus 72. We look for the greatest common factor. I believe in this case it's just 2, so we could divide that out. Dividing out by 2, we get this. I don't see a common factor anymore of any kind. So ultimately now what we need is we need to multiply minus 36 times 4. We compute that. That gives us minus 72. Minus 72 times 2 is minus 144, I believe. Yes. Okay, so now what we're doing is we're looking for the factors of minus 144 that are going to sum to negative 45. So that's a little bit tricky, but let's just go ahead and start listing them. We've got 1 times negative 144. Notice I'm only listing the bigger number as negative because we've got negative 45r. 2 times negative 72. Does 3 go into it? Yes, it does. Let's see how many times. 3 times minus 48. And actually we can stop there. Notice 3 and minus 48 do add to give us minus 45r, so I'll pan down and we'll write that down. We're going to split up the minus 45r into the two pieces that we just found. So we get 0 is 4r squared minus 48r plus 3r minus 36. Now we factor by grouping. This is the AC method. So we learned this method earlier on in the term. We pull out the greatest common factor. That's 4r here. We get r minus 12. And we pull out the greatest common factor here. It's 3. And we get, again, r minus 12. Not a coincidence. And lastly, we end up with 4r plus 3 times r minus 12. We've factored out r minus 12. Imagine you're covering this up. All that's left is 4r. You cover this guy up, all that's left is 3. So that's why you get 4r plus 3 here. But review the AC method if that's not clear. Now, we can see that this is equal to 0. Oh, I forgot equal to 0 here. So since this is equal to 0, we can solve for when each individual factor is 0. But here we get r is negative 3/4. That doesn't make sense. The speed of the boat in still water wouldn't be moving backwards, so this kind of answer doesn't really make sense. But we do get r equals 12 from this problem. So r is 12 miles per hour. We do sometimes get answers that don't make sense, but just think about which one does and write that as the final answer. Alright, let me zoom out. See all that we've done. This was a long problem. It was very involved. But setting it up is usually the hard part, and then once you get to this stage of it, it's just some calculations that you already know how to do. So what was new was going on in this stage. But you can always create a table to help you along the way. So that's it for this video. That's the speed of the boat in still water, 12 miles per hour. So yeah, that's it for this video, but if you have any questions, please bring them up in class or drop a comment on the video and I'm happy to answer it. But I suppose I'll see you all in a future video.